Hello guys, welcome to my YouTube channel. So today we will be solving Leetcode weekly contest 373 problem third 2948 make lexicographically smallest array by swapping elements. Okay, pause the video, read the question, then we will proceed. Cool. So what the question says that you will be given a zero indexed array of positive integers and a positive integer limit. Okay, so basically we will have one array and one number limit. Okay, now what can we do? There is one operation defined. In that operation, what we can do, we can just pick any two indices and swap their values only if the difference between those values is less than equals to limit. Okay, and now it says that return the lexicographically smallest array that can be obtained by performing the above operation any number of times. So it's saying nothing but it's saying that we will be given an array. Okay, so in one operation we can select any two indices ij such that the absolute difference between nums of i and nums of j nums of j should be less than equal to limit. Okay, so that was a condition. Now following this condition we have to return lexicographically smallest array. And what does that mean? That means that, let's say here we have one array. So 2, 10, 3. This is one array. Okay, but this is not lexicographically smallest. We are not following the condition over here. Let's say if we have two different arrays, then the first number, which is the smaller, will come first. So I mean 2, 1, 3. The lexicographically smallest element of all these three elements will be 1, 2, 3. So I think you got the idea, right? It will be kind of smallest or non-decreasing order. So now, if you'll see, we have a limit over here that we can only swap if the difference is less than limit. So I mean, what does that mean? Let's say if it was 100, here 10, here 80, and let's say 20, and I am saying that limit is limit is 5. Limit is 5. What does that mean? If limit is 5, then we cannot swap any two numbers. Why? Because if we'll select 10, sorry, select 100, there is no number with whom the difference is lesser than equal to 5. No, but let's say limit is 10. Okay, or let me add one number, or make it 20 and 10 over here. So let's say in that scenario, if limit is 10, then what can we do? We can switch this 20 with this 10, and we will have a better result, or more, or lexicographically smaller result, and that will be 100, then 10, then 80, then 20. Okay, so if you'll see, you'll notice one thing, or let's go it in this direction, that if say let's say there was no limit, or no limit in the sense, let's say it was infinity. What will you do then? If the difference between two numbers can be infinity, that means we can select any two numbers. So continuing this example only, if our limit is nothing or limit is infinity, that means can we select these two numbers? Yes, we can select these two numbers. So what I'll do, I'll select these two numbers and will place 10 over here and 100 over here. Now out of and these two numbers will be as it is. So in the next operation, what I'll do, I'll select this 100 and this 20, and it will become 10, 20, 80, and 100. So if there was no limit, what we realize, we can switch any two numbers, or we can swap any two numbers. But in the question we have that we can only swap the numbers whose difference is less than limit. Okay, so let's say if there were few more numbers. Okay, few more numbers, or in this scenario, let's say the limit was how much? Let's say 90. Okay, then we will be able to swap everything. So in this scenario, the limit was 90 for our case here, or here. Let's say the limit was 90. Then if the limit was 90, we will end up with this result. But let's say if there was another value, 200 over here. So what will our array look like? Our array will become something like this, that 100, 200, 10, 20, 80, and our limit is limit is 90. Limit is 90. Now, now what you'll see, we can we take this 100 and this 10 and swap it? Yes, we can do. So 10 will come here, 100 will become here, come here, and rest will be left at is it after one operation. Okay. In second operation, what we will do? What we'll do? Will again, or let me write it over here as well. So what we can do? We can select this 100 and this 20 and make our array something like this: 100, 200, 20, 100, and 80. And in next operation, what we can do? We can do make it something like this one: 10 and swap this 100 and this 80. So 200 will be as it is, and here it will be 20, here it will be 80, or here it will be 100. Okay. Now let's say instead of 200, or better, let's write one more here. Instead of 200, make it 300. Okay. And here we can add one more element, 210. Okay, so we have modified this element and we have added one more element, 210. Now if you'll see, can we use the newer elements with our existing ones, or the ones we have used right now? No. So our old elements like this 100 or 10 or 20 or 80, with these elements we cannot choose this either 300 or 210. Why? Because the difference will be greater than 90. Okay, the difference will be greater than 90. So our this final array will look something like this one. So it will be 10, then here we would have been left with 300, here we would have been left with, sorry, here it would have been 20, here it would be 80, here it will be 100, and here it will be 210. Now you'll realize one thing. Okay, now we can select this 300 and this 210 and can swap them. So our final array will become something like this: 210, then here 20, here 80, and here 100, and then here 300. Okay. So from here, what we realize, that we are kind of separating everything in a group. So this is kind of one group. Sorry, this is kind of one group, and this is another group. Okay, listen carefully what I am saying. So if we group the numbers, okay, first of all, what we'll do, we kind of sort them. Okay, we'll sort them, and then we can group the numbers such that the consecutive difference between them is less than equals to limits. Okay, listen carefully what I am saying. So from this example, what we realized, that we were able to sort the numbers. We were able to sort the numbers such that the smallest number and the largest number in that particular group, the group I am talking about right now, is this one. So if we'll sort this number, then it will become 10, 20, 80, and 100. So the difference between two consecutive is always less than equals to 90. And why we are just talking about the difference between two consecutive? Because see, if I have three numbers like 10 and 20 and 100, okay, and let's say 100 was here and 10 was at the end. So let's make it here. So and limit was 90. Limit was 90. So even though, or let's say limit was 80. Better, right? Limit was 80. Okay, limit was 80. So even though we cannot directly choose these two numbers, and swap them. But we can, what we can do is, first of all, we can swap this one and then we can swap this one. Right. So I mean, with 20 we can always choose either 10 or either 100. So we don't need to choose 110 directly. We can use 20 to make them sorted. So first of all, what we can do, we can replace with like, make it 20 over here, 100 over here, and 10 over here. Then selecting 20 again with 10, and it will become 10. It will be remain as 120, and then again selecting this, it will make 20 and 100. So what we realize that if we kind of separate all the numbers in a group such that the difference between two consecutive numbers is less than equals to limit, that means we can arrange them in the ascending order. Okay, listen carefully what I am saying is, if we have group of numbers where the difference between all the numbers in its sorted form, okay, in the sorted form, in its sorted form, if the difference between two consecutive numbers is less than equals to limit, that means we can sort that entire array. That's it, my friend. That was the answer. So in this question also, what we'll realize that if we have different groups, so let's say I'll use different colors for, let's say this was first group. Okay, A1, A2, A3, A4, A5, and something here it was like B1, B2, and B3. There were three members in this group, and there was, let's say, another group. Here it's a C1 and C4 and sorry, C2 and C3. Here the colors are representing one group. So what does that mean? There will be one group such that the sorted order will be only consisting of this one, A1 till A5. We'll sort this, and what will happen? The consecutive difference. So whatever the number, let's say here it was A3, A2, and let's say here it come A4. So the consecutive difference between these two elements will be less than equals to limit. The this difference between these two elements will also be less than equal to limit. Similarly for this one and this one, and there will be second group, and there will be second group of this one, b1, b2, and b3, and once sorted, all here also the same condition will follow, that the difference between two consecutive element will be less than equals to limit, and same goes for c3. We can make another group. Now once you will realize, when you will see this, then you will realize that the last element and this element must have difference greater than limit. Listen carefully what I am saying. This was the first group, right? This was the first group, and this was the last group. This is the second group. Okay, so if we are saying that all the elements in this group have difference less than equals to limit, and we were not able to put this element here, what does that mean? That means that this b1 should be greater than a5 by at least by limit. So what does that mean? That b1 minus a5 should be greater than limit. That's why we separated it. Or if this was the first group, then what would happen? That this b3, like a1 minus b3, should be greater than equal to limit. So now what we realize, that first of all we will separate them. We will separate all the groups, okay, in different groups, all the elements in different groups. And now in all these group, let's say here it was, let's say we have four numbers like 1, 4, 7, 10, and here we had like 20, 30, and 40, something like that. Or I think let's write a better, make it 23, so that we can have some kind of values for limit, right? And here also make it 24 instead of taking it like, and there was one number here, let's say 31 and 34, something like this. Okay, now the initial order of the array was something like this: 124, here it was comma, okay, 124, then again 7, then 23, then 34, then 24, then okay, what elements are left? 31, let's say, and 10. I hope everything is covered. One is remaining, I think. Yeah, one is yeah, no, sorry, we have covered that. So initially we have this array, and you will see that our first group is this one, this 4, this 7, and this 10. Now our second group is this 20, this 23, and this 24, and our third group is this 34 and this 31. Okay, it is 31. Okay, that's it. Let's think it as 31. So now we know that we can only arrange one particular group in the sorting order or the sorted order. And remember one thing, we cannot change their position outside of that group. So if we are talking about this first group consisting of 1, 4, 7, 10, that means we will be only sorting this groups, and we know that this group's positions are fixed. That is, the first position, one position will be here, another will be here, another will be here, okay, and the last one is here. So what we'll do, we'll sort and place this on these positions. So if this is the array, what we'll do, I'll just put first element over here, Okay, and just a second, let me make it. Okay, something like this one. Okay, so here 4, then here it will be 4, then here it will be 7, and in the last position here it will be 10. It was already sorted, so we don't need to do anything. Now, if we'll see the second group, if we'll see the second group, this is 20, here it is 23 and 24. My bad, I already take the sorted example. So here what we'll do, we'll put 20 over here and then 23 over here, and this 24 would be here. Now, for the last group, what we have? For the last group, we have this 23, sorry, 34 and this 31. So we can sort this in between in themselves, and final array will look something like this. Okay, so you'll realize that the each group is sorted in themselves, but overall they are not sorted. Okay, and this will be the best lexicographically possible result. Now, how we will do it? So we can, first of all, we can make vector of pairs. We can make vector of pair. Okay, we can make vector of pair, and we can sort it. And the first value will be the value. The first will be the value or the nums of I. Okay, the nums of I, and the second value will be I. Now, first of all, we'll push all the elements. We'll push all the elements and then sort it. Then what will happen? The all the elements will be sorted on the basis of their value, and with each value we'll have their index as well. Now, as we said, what we'll do, we'll put all the elements in, if the difference between two elements is less than equal to limit in their sorted form. So this is the sorted form, right? This is the sorted form. After the sorting, what we'll do, we'll just keep on pushing, or we'll make one group out of all the elements till the difference is less than equal to limit in two consecutive elements. Okay, so let's say till here there was one group formed, then here to here another group formed, and then in the last we have another group formed. Okay, so in total we would have three groups. Okay, and this will be exhaustive, so all the elements will be taken. And now for this group, what we'll do, we will just take this group. Well, as we know that this was already sorted by values. Right? Now what we'll do, first of all, we'll take out the indices of all these elements. First of all, what we did, we take the first group. Then we collected the indices, because indices are not sorted, right? We collected the indices, then we sort them, and then whatever the first index we have, we put the value of this first element from this group, because the value, it was sorted on the basis of value, right? And here we have new array which is sorted on the value of index. So what does that mean? Let's say, if like in this example, if instead of 1 over here, let's say here it was 7 and here it was 1, so we know that 1 must be placed before 7, and in the indices we have this index, and this index. Okay, but after sorting, this would have come a bit early than this one. Why? Because of the value 1 over here. So we need to collect this indices, whatever the indices we have, and we sort the indices as well, and then we put this first at the first index, this index, and then 4 at this index, then 7 will be go to this index, and the 10 will remain as at its index, right? So that's what we will do. Now come back to the code, make it, that will make you more clear. So what we did, first of all, we created a vector sorted. What will sorted contain? Sorted will contain all the numbers in their pair form as in their value and their index, and sort them, let's sort them on the basis of their value. So now we have this sorted vector completely sorted based on the value. Now we have to divide them in groups. So what we can do, we can make a vector of pairs. Why vector of pairs? Because we will be making one group, right? And in one group we will have pairs. So that will be nothing but vector of pair, and then we can have multiple groups, right? So it is nothing but the vector of groups, and one group is nothing but the vector of pairs. That's why we have made vector of groups. Now we know that the first element is anyways going to be the smaller in this sorted array, right? So we put the first element, or started our first group and put the first element in that, and Then we started from the position 1 in the sorted array, and we check if the difference from the last element is less than equals to limit, and we are comparing the first elements. I have defined this f as first. Okay, and if that's the case, so in the groups we have the group containing all the members of a particular group, right? So if there were two groups, we have to push in the last group, right? So we just in the groups we checked out what is the last group, and we have compared it with that only, because we are always comparing with the just previous element. So if the difference is less than, so we will push it back into the last group, else we will start a new group. Okay, and finally we have made an answer of size nums, not size, whatever the answer we have required. Now for each group we are collecting all the indices in this index, in this indices vector, then we are sorting this, and for from we are picking the elements from this group and assigning on the indices, and finally returning the answer. Okay, it's an AC solution. Okay, I hope everything would be clear with you, but if you guys face any issue in this, any doubt, do let me know in the comment section. I'll try to help you as much I can. Okay, thank you guys, see you in the next video.